What is up, everybody? So we are now into 5.3, dealing with altitudes and medians of triangles. So this one hopefully seems a little bit easier because we talked about circumcenter and in-center, and so hopefully understanding these diagrams is going to be a little bit more fluid. So let's go ahead and jump right in. So when you look at that triangle on the left, right, we know that this green point right here is a midpoint because we have those two single dashes on the left and on the right. We also know that that red line is perpendicular, okay? So right now, that red dotted line is actually a perpendicular bisector to that triangle, okay? And so that kind of takes where we left off yesterday, but now we're going to talk about altitude and medians. So an altitude of a triangle is perpendicular to a side and connects to the opposite vertex of the side it is perpendicular to. So an altitude does not have to be at the midpoint of a triangle. That's super important, on the midpoint of the side. It just has to be perpendicular to a side and connect to an opposite vertex, okay? So that diagram on the right, this length could be different than this length, which means our green point is not necessarily a midpoint, but that's a good example of what an altitude is. It has to be perpendicular to a side, and it has to connect to the vertex opposite the side it is perpendicular to, okay? Next, we have a median. So a median, it kind of connects, it's kind of like a mix between a perpendicular bisector and altitude in that it connects the midpoint of a side to the vertex opposite that side. So notice that that red dot right there is the midpoint of this yellow side, but obviously that line that connects the red to the opposite vertex is not perpendicular to our yellow side. It's not forming a right angle, okay? So medians are connecting the midpoint to the opposite vertex. Altitudes are perpendicular to a side and connect to the opposite vertex. Now, for an isosceles triangle, the altitude and the median are the exact same thing. So if I look at that triangle right there, I know it's isosceles because we have these two sides that are marked with a single dash, okay? And then I also know that this point down here at the bottom is my midpoint based off my double dashes. And so notice that that altitude, so that's perpendicular to our bottom yellow line, and it's also connecting to our opposite vertex. So it's kind of like two birds, one stone with an isosceles triangle. So the median and the altitude are the exact same thing in an isosceles triangle, all right? Now, most of what we talk about today is going to be focused on medians, but before we do that, I just want to review some small things regarding isosceles triangles. So as I look at this isosceles triangle, okay, I know it's isosceles because we have 10 and 10. If I were to draw in my altitude, I know it's perpendicular, and I know it cuts these two sides in half. So I know that this would be 9, and this would be 9 here. Now, a common question that you kind of see a lot is, what is the height of this triangle, or what's the distance of the altitude, right? And so that would be this distance right here. Now, in order to find that, okay, let's go back again. So a question might be, what is the altitude of this triangle? Well, knowing it's an isosceles triangle allows us to draw the altitude in, and we're trying to find, a lot of times height is referred to as altitude. We're trying to find that h. Well, knowing it's an isosceles, I know that this is a midpoint, so I know this is 9 and this is 9. So what we now have, if we were to pull this apart, is a triangle with a hypotenuse of 10, a base of 9, and we can find that third side using our Pythagorean theorem. Now remember, with Pythagorean theorem, the hypotenuse is always the side opposite the right angle. So if I have a triangle A, B, and C, Pythagorean theorem is a squared plus b squared equals c squared. So in our case, that would be h squared plus 9 squared equals 10 squared. H squared plus 81 equals 100. H squared equals 19. And then taking a square root, that would be square root of 19. Or if we wanted to get the actual decimal value, that would be the square root of 19 using a calculator, would be 4.4. Okay, and so I know that doesn't seem to scale because technically if I were to draw that, it would be 10, 10, and 18. It would be much more spread out, kind of like this, where it'd be 10, 10, 18, and now when we draw it down, this becomes 9. This being 4.4 is a lot more realistic now, okay? But knowing that you can use Pythagorean theorem to solve for the height of an isosceles right triangle is kind of a big deal when we move on. Now, our homework doesn't cover that, but I wanted to make sure we covered that before we move on to the main parts of the homework. All right, so here's the main thing that we're looking at for homework today. So when I look at our diagram here, notice that x, y, and z are all midpoints of our triangle's sides. Again, we know that because we have single dashes, double dashes, triple dashes. That means that all of our red dotted lines are medians, okay? And so notice point D, where the medians are intersecting. Where the medians intersect, that is called the centroid. All right. Now, the centroid has actually a really important significance because that's actually the balancing point of a triangle. So, what do I mean by balancing point? I mean, if you were to cut a triangle out of cardboard, find the midpoint of all the sides, draw a line from the midpoint to the opposite vertex, making a median, and you did that for all of them, and then finding where they intersect, that's the centroid. If you took a pencil and then put the pencil tip at the centroid and then let go of the triangle, if you do it carefully, it will balance on the tip of your pencil on the centroid location, which is pretty cool, right? So centroid math is used a lot for a lot of type of hanging architecture or hanging decorations or sculptures. Now, the big part about the centroid, though, that we need to understand for our homework today is how those lengths interact. So I want to draw our attention to median BZ. All right, now median BZ is broken up into two different segments. You have segment BD and segment DZ. Now, what's going to be important here is that BD's length is always going to be a consistent ratio to BZ. So what do I mean by that? I mean that the length of BD is equal to 2/3 of the length of BZ. So the distance from the vertex to the centroid is always 2/3 the length of the median. Okay, I'll say that one more time. The distance from the vertex to the centroid is always 2/3 the distance of the entire median. So we did that for our other ones. CD is equal to 2/3 the length of CX. And AD is equal to 2/3 the length of AY. which then by default means all our little short ones, dy, dz, dx, those are 1/3 the distance, or 1/3 the length of the median. Okay, and we're going to do a lot of practice on that on the next slide. So just know that this is what the majority of your homework is on today. But before we do that, I want to briefly just talk about the orthocenter. So now if you look at the diagram, right, all of those purple lines are the altitudes. Now there's no special formula for the altitudes or anything like that, but I just want to fill you in on what the name of the intersection point is. So the point where all the altitudes intersect, that is called the orthocenter. Not as important as the centroid by any means, not as important as the incenter or the circumcenter, okay? But it does have a name, and that's pretty much all that you need to know about that, is that where the altitudes intersect, that is the orthocenter. So let's take a look at what your homework was going to look like, all right? So here's our diagram to the right. So this is almost an exact replica of what your homework is going to be like. Notice that E, F, and D are midpoints. Once again, I can tell that by looking at my diagram, right, with all the slashes. Then they give us some lengths. They tell us that C to P is 30. They tell us that EP is 18. They tell us that BF, so BF is the only median that we have the entire length for, that BF is 39. Okay, so that entire length is 39. So we have to find the missing lengths based off of that. So let's go ahead and look at number 1. So number 1 is asking us to find the length of PD. Okay, so PD is right here. Now we know that CP or PC is 30. Now my advice is find the length of the entire median first, then you can find everything else. So I know that 30 or CP equals 2/3 of CD's length, right? So 30 equals 2/3 of CD. I know CP is 30, right? CD, remember, this is kind of like a placeholder. It's like a variable. I could put 30 equals 2/3 x. It's the same exact thing, okay? So now, to get CD by itself, I just need to multiply by the reciprocal of 2/3. Okay? So then these would go away. 3 times 30 is 90. 90 divided by 2 is 45. So that means CD's length is 45. And what do you know? CD is 45 right there. Now, if CD is 45 and CP is 30, then PD is 15. 45 minus 30. Okay. BF. So we're trying to find FP. FP is right here. Now, my advice is always find the 2/3 length first. So I know BF is 39. So this whole thing is 39. So that means that BP equals 2/3 of 39, or BF. Okay, I'll put BF just so we can have it there for reference. And then you plug that 39 in. So BP equals 2/3 times 39. Well, 2/3 times 39, 39 times 2 is 78. 78 divided by 3 is 26. So that means that BP equals 26. Draw a little 26 there. This was 15. So if BP is 26, then PF is 39 minus 26, or 13. Okay, I'm guessing they asked for BP somewhere else. Yes, they do. It's 26 right here. And now for our last problem, okay, we are asked to find PA and EA. Well, we know that P to E is 18. That's the only thing that we know. P to E is 18. Now, if AP is 2/3 of EA, then that means that PE is 1/3, right? So that means that PE equals 1/3 of AE. Well, I know PE is 18, so 18 equals 1/3 of AE or EA, doesn't matter. So what I'm going to do is I'm going to multiply both sides by 3. 18 times 3 is 54, so that means AE equals 54. Just so happens we're trying to find that right there. So then to get PA, it's just 54 minus 18, which is 36. Okay. So a lot of it's just using that formula. The vertex to the centroid is 2/3 the length of the median, but you can always use centroid to midpoint as being 1/3 the length of the entire thing as well. It's kind of up to you on how you want to do that. All right, and just so you know, the next page, so this right here, same exact concept. They just tell you that this is a centroid, which makes Y, R, and N midpoints, and you would just go about doing that problem the exact same way. Okay.